Hello, everyone. How's everybody doing? Had a little trouble there with the URL. The YouTube folks changed it on me, so I don't know if they're giving you a new code every time. I don't know. First time it happens. Anyways, that's why I'm a little late. Um, Today we're going to continue with an exciting topic: nothing. Yeah, we started this little train of thought couple weeks ago. It started with what? With the modern contemporary physicists, mathematical physicists, mathematicians, as I call them. Yeah, I'm waving, Pedro. Um, and they claim that they can create a universe, matter, right, from absolutely nothing. Talk about a magic trick. That's as witchcraft as it gets. Yeah, they say that the universe came from nothing. And, when you listen to them a little bit, people like, what's his name? Lawrence Krauss. He says that, eventually you end up with that it did not really come from nothing. It came from something else. And they call that other stuff energy. And so the question is, where did all this come from? If it did come from somewhere. And so when you look at the issues, you try to find out, where it all started. Where did people come up with all these ideas? Is this the first time we discuss these issues in the 21st century, maybe even in the 20th century? And the answer is no. When you go back in time, you go all the way past the 19th century, which obviously they did talk about these issues. 17th century scientific revolution also talked about these issues. And you go all the way to Aristotle and Plato and even beyond. People from Thales of Miletus already, 600 years before Christ. They were discussing these issues. And I'm sure there was someone even before them that talked about it. Okay. So I don't even think that these issues come from that period of time. Maybe, I'd hate to speculate, but maybe they come all the way to the Paleolithic. After all, all these hunter-gatherers, they just grunted around. They probably looked at the stars up there and said, what are those stars? What are those little lights up there? They had to see that. They lived out in the wilderness, right? And so they probably asked questions along, what is this? Where are we? Even in their primitive minds, they probably had some questions in their mind, about what it was all about. And when you get to more educated, more advanced humans in the Neolithic, I'm sure they looked up there as well and they said, what is this? So I'm sure these questions have been around for thousands of years, for sure. Okay. But we can only go back to more or less the written word, and the written word in the West comes from the Greeks. So that's where our starting point is. You have to remember that people in the East, not only Chinese and Indians, but even less farther east, people like the Babylonians and the Assyrians, they had rich people, they had wealthy people who sat around and had nothing to do sometimes, and they probably asked the same questions. They looked up at the night sky and said, "What is all this about?" And they were a little more educated than the rest. They had to have some questions. So I'm positively sure a lot of these ideas have been around for tons and tons of years. Okay, but in our case, we can take it back to the Greeks. We have a written record, whether they created it, whether they borrowed it from someone else, from a previous culture. I guess we won't know. Only God knows that. He probably knows the first guy who thought about some of these things, and the fellow's name was Uga, maybe some caveman. Only God knows. Okay, so where do we start? Well, we left off, I'll just go kind of quick here. We left off with the Greeks, and we have all these schools, the Eleatics, the Ionians, the Stoics, Epicureans, Platonism, etc. There's been several schools in the old days, in the days of Greeks, and um, and they discussed these issues. What was the nature of the universe? Of course, they could only limit it to the universe they could conceive, which was typically the Earth, the Moon, a couple things that they could see out there, maybe all the way to Jupiter, and so they speculated on the nature of these things, and obviously they saw that black medium in which they all these objects swam, and they had questions about that black stuff. What was it, and so several schools of thought developed. You can pretty much figure out what anyone in the East could have come up with as well, because there are only so many options. Either nothing exists, space, uh, or nothing does not exist. Nothing is just another something. So you can have, nothing being absolutely nothing, whatever that is, right? Or nothing can be something. And then you have the question of whether it's, it doesn't matter whether it's something or nothing. The question is whether it's infinite, right? Because, one thing that you might ask is, yeah, okay, I believe in nothing, that there is something called nothing, and whatever that means to you, however you define it. Then you have the people who say, no, everything is something. Fine, no problem. Either way, you got the same question. Is that somethingness infinite? Is that nothingness infinite? And if you're going to say, well, I'm going to go with the ether, the same thing. The ether is the ether, this alleged medium in which things swim out there in space. Does it extend indefinitely? Or is there something outside of that? And if there is something outside of it, what is it? So, these are the questions that the Greeks try to answer. And these questions have been around, well, at least since 600 years before Christ. We know that for a fact, probably earlier. Okay, but these are the Greek schools. And I'm going to be focusing today real quick on the Eleatics, the Stoics over here on the right, Eleatics on the left. This lower right, you got Democritus. And then somewhere in the middle there, you'll find good old Aristotle. He had his school at the Lyceum in Athens, and later on he became Alexander the Great's teacher. He was hired by Philip, Alexander's father, right, king of Macedonia, who eventually was going to conquer all Greece. And Aristotle just, went to Pelos and became Alexander's teacher. So I want to focus on these four groups because they pretty much represent all the other groups. All the other groups more or less had ideas similar to what these four groups had. Okay, what are we trying to answer? We're trying to answer this. We're trying to answer, is the ether infinite or finite? Are the gods of the Olympus inside the ether or outside of the ether? Did they create the ether like over there, or are they, encapsulated within the ether? And is the ether infinite, or does it stop again? Does it stop at Mount Olympus? Okay, so this is one of the issues that we're going to try to answer, and we're going to try to answer with what the record shows. Okay, we're not going to put words in their mouths. Okay. Here are the main schools that dealt with this issue. Okay, and these folks, you have the Eleatics on the upper left. Okay, and right below them you have Democritus and the people of Abdera, which was in northern Greece, what today is Greece, right? Okay, so Parmenides, he was the founder of the Eleatic school in southern Italy. And he said, the ether, there is an ether, it's infinite. Okay, it's infinite, but it's static. There's no motion in the universe. And you say, how can that possibly be? What do you mean there's no motion in the universe? Yeah, he said exactly that. And he believed that. He said, there is no motion in the universe. How did he explain it? Well, he said, imagine that you take an object and you want to put it into a location that doesn't exist. Then the object ceases to exist. Maybe you're following my train of thought. He said, look, there's no such thing as nothing. Nothing doesn't exist. There is no such thing as nothing. And so what does that mean? It means that you cannot rationalize how you put something into nothing, because essentially what you're doing is turning it into non-existent. And so he says you can't have motion because of that, because motion would require an object to move into a place. And since there's no such thing as a place without a thing in it, what you're actually doing by moving a thing into a place that does not exist is making the object inexistent. That was their reasoning. Whether you agree with it or not is a separate issue, but this is how they thought, okay? And so they said there's no motion in the universe. The universe is infinite, okay? And there's no such thing as space. Essentially, particles push particles all around. And, where there's no air, there's water. Where there's no water, there's fire. And, you get the elements, the typical four elements, plus the ether. Democritus, on the other hand, he said, look, all there is atoms and empty space. So you have all these particles just floating out there in empty space, but space is there between them. And I guess he believed that's why particles move. He didn't really address the issue of whether the universe was infinite. Not that I found, anything in his writings, or we don't have his writing. We have other people writing about him, but no one mentions that, at least on behalf of Democritus. You have to remember Democritus wrote about as much as Aristotle. He wrote like 70 volumes of books or whatever, and none of them survived. We haven't found a single thing from Democritus, but we know he wrote a lot. Aristotle, he picked up a little bit from Democritus and a little bit from the Eleatic school. He said, look, the ether is infinite, no doubt about it. And there is motion, unlike what the Eleatic said. But there is no empty space between these objects, between the forms, as Plato would call them, right? So he disagreed with the Eleatics in the sense that, yes, there is motion. And motion simply means that an object occupies a space that another object left behind. So there's this flow of objects, okay, throughout the universe. So there is motion. And the ether is obviously infinite in his mind. And that's where he disagrees, or the Stoics disagree with him. They came a few years later, maybe 20, 30 years later. And the Stoics, founder was Zeno, not the Zeno of the Paradoxes, which is the guy on the upper left there, Zeno of Elea. This is Zeno of Citium. And Zeno founded the school, and their ideas, the Stoics, they believe that, the ether is not infinite. There is something out there, we'll call it a divine substance, that surrounds the ether. So whatever was out there was in the hands of God. We'll never know, and we'll just speculate or hypothesize that what's outside the ether is the divine cloud of whatever, okay? Who knows what was there, like I say there. Okay, so these are the schools, and these issues were debated among them. You will remember that the Stoics, they pretty much side with these guys, Stoics had this idea that there was something outside the ether. I represented it here with a relativist looking out at a hypercube in the middle of that white region, and that's the divine region. That's what they had in mind. Okay, this is their notion that there was something outside the ether. You had earth, wind, fire, and earth, and outside of that you got the ether, and outside of that, cloud encompassing it all. belonging to the gods, I guess, only. Philolaus, he's a Pythagorean, and he had a similar idea. He says, look, you've got the ether, which is where the stars are, the brown part there, and then outside of that, you got the outer fire. Now, these guys came earlier, and so they came up with this outer fire, but that's what's going to be this divine, uh, I don't know, stuff that only the gods smoke to get high. Okay, the eternal fire or whatever. It was some substance that surrounded the ether. So they had all these different ideas. Aristotle, he you can summarize it with this notion, these points that I put here. Motion occurs when objects influence one another. In other words, you have to have an object pushing something else. Nothing cannot move something. Okay, nothing cannot create something. All of them agreed on that, I guess. Something cannot move into what doesn't exist. Okay, empty space, place, nothing. So why? Because what that something does is actually occupy the space or the whatever that the other object occupies. So it doesn't move into empty space. It moves to the location of another object. That's what Aristotle is saying. So that's a different way of visualizing motion. It's not that an object moves into a region where there's nothing. It moves into a region where something just left that space for them. So there's a flow of things you can think of. And you cannot have empty space between atoms because he pretty much agreed with the Eleatics on that. He did accept negative infinity exists. You can chop something into many parts as you want, but you can't have positive infinity. You can't have positive infinity because it would exceed the capacity of the of the heavens, of where the gods dwelt. Okay? And the universe had no beginning; it will have no end. I'm not sure how he reconciled that with the gods. I guess he didn't believe that the gods created the universe, right? Because if the gods created the universe, well, then it had a beginning. But I guess in his philosophy, he decided it doesn't. Where he disagreed with Plato and some of these others is that the ether exists, but unlike Plato, it exists outside. It's only what the gods breathe. It's not here, on Earth. So you'll never find ether here on Earth. You'll only find the other four elements, earth, wind, fire, earth, water. Okay. So things pretty much continued like this for a while. Here's a way of I like to synthesize it this way. Maybe this gives you a picture of what these people thought of. Okay, you heard of the little puzzle that's got the 15 squares in it. Well, Democritus just looked at it as particles occupying space. Okay, so particle moves into a space. Parmenides and the Eleatics, they did not believe that particles move at all. Okay, because if they move, they would have to occupy a space, but there's no such thing as space. And so if a particle happened to move where there was a space, an inexistent space, it would itself become inexistent. And Aristotle kind of took both of these ideas and he says, look, actually what's happening is that there's only particles and there's no empty space. But a particle occupies the location that another particle left immediately, instantly. So that when one thing moves, something immediately takes that place. And so he kind of summarized or synthesized what came out of the Eleatics and the Abderas, the atomists or materialists that followed Democritus. So these were the ideas that were kicked around in those days. This is a good way of synthesizing it pictorially. Okay, you would think that that in the following centuries, they would have fixed these problems, and it turns out they did. What happened was the ether was identified more and more with the soul. They kind of took Plato's view, and Plato was a little bit of a mystic. In fact, quite a bit of a mystic. And he believed, that this ether that the gods breathed, they kind of blew it into our noses as well, came down to earth, right? And we had it here among us. And people eventually identified that with a soul. They said, oh, look, this comes from heaven. And some of them thought it came from hell. Like if you had the disease, well, it was the soul from the devil or from some evil thing out there. And if you had some good vibes, you had a good luck or whatever. Oh, that was from the positive gods, from the good gods. So the ether somehow was identified with the soul and took off in the direction of religion. And throughout most of the, you could say, next 1,500 years, pretty much, astrologers and alchemists and religious folk who did a little bit of everything. They did a little of alchemy, a little bit of astrology, and they did a little bit of, religion, traditional religion, Christianity primarily. And they all pretty much believed in this ether, and they identified it with a soul. And only those people, you could call the scientists of the day, the astrologers and the alchemists, the guys who worked in their little basements, well, they identified the ether more with astrology, with the stuff they saw out there, or with chemicals. They were more materialistic in their approach to the ether. And they did study Plato, they studied Aristotle and some of the other Greeks. But the majority of people out there, they thought of the ether as, some kind of spirit that was identified with the soul. So the ether was taken largely by religion, okay, and it was converted into the soul. It doesn't really revive until the 17th century. That's pretty much when it started to pick up speed again in the direction of, first in the astrologers, in the direction of the astrologers and the alchemists, but eventually, it was taken over by the mathematicians, people who started doing math, and they started inquiring about the nature of our universe, and they said, let's look into this. What is this ether stuff? And they all believed in the ether. They just tried to make sense of it. And again, they also studied Aristotle and the others, primarily Aristotle, because now you get into more a scientific approach. You do a little bit of research, you try to rationalize it, whereas the religion just took it and mixed it with the spirits. And it was heavy stuff. I mean, if you had the wrong ideas, you could be killed for it. One famous guy who was burned at the stake because of his ideas on cosmology was Mr. Giordano Bruno. And he was a priest. He went all over Europe. He wrote several books. A lot of them were burned after he was executed. The Vatican, the church, decided to give him early retirement. And they tried him and they burned him at the stake. He was burned upside down. He was burned nude upside down. They really wanted to punish this guy. They kept him 7 years in prison. 7 years that his trial lasted. 7 years. And they finally executed, burned him at the stake. What was his crime? Well, he had several crimes, related to religion, but these are the ones that are related to the universe and to the things that bothered the church from, you could say, from the rational side. People who tried to make sense of the universe on their own without consulting the Bible or without really following, what the Bible is saying. And for example, Giordano Bruno did not believe in this transubstantiation, that bread and wine turn into really, to the body and blood of Christ. And this was heresy. On the other hand, he believed in the transmigration of the souls. So he believed that, when you die, your soul goes out there, and then eventually, if you were a bad boy, your soul would end up in some kind of animal, maybe a cockroach if you were very unlucky or very bad in your life. So, you had to be a good guy so that your soul would migrate to the right kind of entity out there. He was also accused of dealing with magic and witchcraft and divination, so on. But related to the ether and the universe and infinity, he believed in the existence of many Earths, in other words, many worlds, and that they were populated just like the Earth was. In other words, not only was the Earth not the center of the universe, as was heavily believed until those days, but it turns out that he believed that, Christ is only on this Earth. How about, is there a Christ in some other Earth? And that was what he was essentially challenging. He was saying, look, there's many worlds out there, and that was heresy. That was dangerous, because you were saying, oh, just Christ is just one of many. Kind of, you were putting the good Lord down, and he believed the universe is infinite. In other words, that space was infinite. And this is something he did write. He said the universe is then one, infinite, immobile. It is not capable of comprehension. You cannot comprehend it. Okay, so therefore it is endless and limitless. Okay, so Giordano was saying, the universe, you cannot comprehend it. That's why it's infinite. It's beyond our imagination what's out there. Okay, and in that sense, it's infinite, unlimited, because it's like we can never grasp what could be out there, encapsulating it. Okay, so in this sense, it was. And they gave him early retirement. Shortly after, about the same time, but shortly after him, we've got Rene Descartes. He's one of the guys who really starts putting fuel together, by the way, with Galileo. Galileo was a little earlier than Rene, but they did write letters to each other. Okay, and Descartes essentially believed that the universe was made of particles, just like Democritus proposed. But he didn't believe in empty space, like Aristotle believed in. In other words, he essentially took the view of Aristotle. He says, look, there's particles, but there's no such thing as empty space, and it cannot exist for the same reason. Matter would instantly occupy that space. Okay. He did change. He got rid of one of the four famous elements. Okay, he got rid of water, and he created three laws of motion. Two of those are going to be incorporated into so-called Newton's laws of motion. Newton really came up with number two: force equals mass times acceleration. The other two laws of motion of Newton, they come from Descartes. Something moves in a straight line, and something needs to push something else in order for there to be motion. And again, these ideas were, Newton did read Descartes, and he incorporated his ideas into his book. Then the other one that he came up with, or really did not, but he subscribed to, was circular motion of the particles of ether compel planets to move around the sun. Okay, and that comes from Aristotle. Aristotle was the first to come up with that idea, or at least we know that Aristotle believed in that. I don't know whether Aristotle was the first one to come up with it. Again, we don't know who all these people were who created all these things originally, but Aristotle believed that the ether moved in circles out there, beyond the gods, and that's what pushed the planets in circular motion. And the cause of gravity was so funny that he says the ether is lighter than the air. That's why air doesn't go into the region of ether, and likewise stones don't go into the air, because the air is lighter than the stones. Okay. What he did believe is that the ether particles that fill space have the ability to transmit light to particles. He believed also that light travels instantaneously. And he got that really from Galileo, who had run an experiment with his friend, his assistant, on another mountain. He unveiled his lamp and told him to unveil his lamp as soon as he unveiled his, and he couldn't figure it out. It was always so instantaneous that he says, light travels instantaneously, and Descartes believed in the same thing. Of course, Descartes died in 1650. A few years later, it's Romer who's going to demonstrate that light does have a finite speed when he observed the moons of Jupiter coming later than they were supposed to, and that was because the Earth was on the other side. 6 months later, he looked at these moons for 6 months, for a full year. And when he calculated when the moon was supposed to appear, it didn't appear. It appeared a little later. He says, oh, the delay is due to the speed of light reaching our eye. And it was Huygens, Christian Huygens, who was going to calculate the speed of light, little on the low side, like 10% or 20% off from the real value. But he said it's even faster than what he calculated. So at least they found out at the time that Galileo and Descartes were wrong. Light does have a finite speed, and this triggered other people later to get into the game. One was Bradley, who's going to show the speed of light through parallax. He's going to reach a much more accurate value, and that's in the early 1800s, the 1720s, I think it was, around the time that Newton died. Okay, so Rene, he had his ideas, and some people give him credit for coming up with a wave theory of light. I don't think that's true. I looked, and I have searched in several years on this issue. I've never seen anything related to the wave from Descartes. Descartes was a particle man. In fact, Newton, generation later, is going to reference Descartes and say, that he more or less agreed with Descartes that it was all particles. He believed in particles. He was a particle man. He was like Democritus in that sense. They believed that it was atoms in empty space. And what were the atoms? Well, it's all these little particles that fill the vacuum, and we're going to call them ether. And in that ether, there is no space. Remember that. How the particles are separated, they never figured out. I mean, they never told us. But they say particle is next to particle. What's in between them? I don't know. What contours the surface of a particle? Are the particles round? Are they cubic? We don't know. And again, what's in between them? We don't know. All we know is that one particle pushes the other one, and that's how everything moves. And so this was the universe that these people had, and they saw it as particles. But then a fellow that comes up, he's the one I always credit with the wave theory of light, even though it was a little nebulous, but he's like the beginning of the wave theory of light. And there may be people who disagree with me. Maybe they have more information. I don't know. But all I can tell you what I think right now, and I think it was this man, Robert Hooke. He writes his book, Micrographia. He wrote it at the end of 1664 and published it in 1665. And Robert Hooke, he believed essentially that after looking through the microscope, he was looking at many things. Specifically, one of the things he looked at was tobacco. He looked at the first man to look at tobacco, I think. And he analyzed it in quite a bit of detail in his book. He just the book is just a bunch of drawings of what he observed through the microscope. But he comes to the conclusion that light seems to propagate as a wave. And he does mention several things in his book. Here I pulled a little couple excerpts so that you get an idea of what was going through his mind. He said this stuff is the right side of it be looked upon. Years appears to the naked eye all over so waved. Okay, he starts using these words like wave and undulated, or grained with a curious though irregular variety of brighter and darker parts, that it adds no small gracefulness to the gloss of it. Those parts which appear the darker part of the wave in one position to the light, in another appears the lighter, and the contrary. And by this means the undulations become transient. Again, you can see he's talking about waves and undulations, right? And in continual change according as the position of the parts in respect of the incident beams of light is varied. He doesn't completely rule out the ether. As you can see, we are yet unable and ignorant of the ways of precipitating air out of the ether. So he still has the ether in the back of his mind, but he thinks of it more in terms of waves, or he's visualizing as waves. That's how he writes his book. But he can't get rid of the particle. You can see that in another paragraph in his book. For particles that are not similar will, like so many equal musical firings equally, vibrate together in a kind of harmony or unison. In other words, he's talking about particles vibrating. Okay, I guess that's his notion of the wave, particles vibrating. And he says they have the agitating pulse. Again, agitating, he's talking about motion, vibrating motion, undulating motion. Yet make quite different kinds of vibrations and repercussions, so that though they may be both moved, yet are their vibrations so different from each other to their similar particles. So this is a fellow who believed in that light had some waviness to it, some undulatory properties. And he figured this out because he saw these different bands, light and dark bands, as a halo in the images that he observed. He said, it looks like light has this waviness to it. He got this notion. And so I credit Robert Hooke as being the first guy who really zeroes in on the wave. Of course, this is going to progress, and the guy who's going to get a hold of it and treat it formally is going to be Christian Huygens. Okay? And they had a little debate between Newton and Huygens, and really, I can't figure out what the debate was about, because as far as I'm concerned, whether you read Huygens, whether you read Robert Hooke, whether you read Newton, you're going to find the same thing. You're going to find they talk about it, and but for that matter, if you read Descartes as well, they all talked about the ether. They all talked about particles making the ether. These guys talk about waviness of those particles, and the other guys, I think the only thing they were saying is that these particles travel straight. So I think it was just an issue of straightness versus undulating. That's all I can think of, because other than that, I don't see any difference between anybody in the 17th century. They all talked about ether being made of particles. So, and that thought, and the reason I'm mentioning this, is it's going to last all the way to the 19th century. They're going to talk about particles, and 19th century is a century of waves. What are they talking about? The movement of particles. So they talk about waves, but what is a wave? Wave is the movement of particles. And that's why I keep asking all these wave theorists today, yeah, I know people believe in the wave, but what is the wave made of? And, they have two answers today. Some people say it's made out of nothing. And they turn that around slightly on you and they say, well, light does not need a medium through which to travel, which is not the same question is, what is the wave made of? What is light itself made of? Because assuming it can go through empty space, and empty space is absolutely nothing, and light does not need that medium through which to propagate. It's like saying there's no ocean there. Fine. But that doesn't mean that light itself is not made of something. Okay? And if light is made of something, what is it made of? Particles? Is that what's going up and down, in a wavy form? So this is the issue. And this starts already in the 17th century when these people are trying to address these issues. And again, I credit Robert Hooke with those ideas. Newton believed in the ether too. People think that that Newton was a particle man. Yes and no. He was also a wave man. He was because he believed in the ether. And he says he writes to Robert Boyle, who was an old man by the time. He was Newton's senior, and so Newton had a lot of respect for him, and so writes to him this letter. And you can go through it and find, he talks about the ethereal substance. He just talks about the fact that the ether is rare here and more dense over there. And that's how he explains the behavior of light in this letter to Robert Boyle. I don't want to go through all of this. I just want you to know that Newton believed in the ether, and he believed that the ether was made of particles. And the only issue is he talked about the ether being denser here and lighter over there. the inside the object, the ether had a certain density, outside of it had another density. And with these notions, Newton tries to explain, and he will do so later on as well, he tried to explain the behavior of light. Okay? So that was Newton's version. He thought of it as particles, but again, the only thing I can think of is that Newton is trying to say that these particles travel straight. That's a difference that I see between Newton and Huygens, who's going to come up next, and Robert Hooke, with whom he didn't get along, and they had a lot of arguments. Especially Robert Hooke accused him of stealing a lot of his ideas. But they had all these clashes, and the clashes, as far as I can tell, is that Newton's particles just travel straight, the other ones, undulate. That's it. That's the difference. One vibrates, the other one doesn't. Because other than that, they all believed in the ether, and they all believed that the ether was made of particles. And not all of them believed that there was empty space between the particles, but you have to go farther and farther back. Today, I don't know if there are too many people out there that believe that the ether is not within space, or does not have space between the particles. I don't know. I'd have to find out what people think out there today, but I haven't heard that argument still. Anybody addressing that issue? Okay, what does Huygens say? He was from Holland. Okay, and Christian Huygens, he writes a few years later, 1690, about 11 years after Newton talked to Boyle. Newton, by the way, is going to write another book on optics where he talks about light. He's going to publish that book in 1704, 14 years after Christian Huygens. And Huygens believed that light was some kind of undulation in the ether. He says the successive movement of light being confirmed in this way, it follows, as I have said, that it spreads by spherical waves. People today claim that they invented the spherical wave. They haven't read Treatise on Light from Christian Huygens. Huygens already invented the spherical waves, okay? Like the movement of sound, okay? And remember that sound moves longitudinally. And so he was saying that, but see, he is later going to describe it like a stone falling in the water. And a stone falling in the water, the waves in water, they move both ways. They move longitudinally and transversely. They move perpendicular to the direction of the wave. So if the wave is moving in a given direction, it also moves orthogonally with respect to that, direction. Okay, and it says, in which the movement coming from the luminous body is propagated, I call ethereal matter. Okay, so he believes in the ether. Okay, now in applying this kind of movement to that which produces light, there is nothing to hinder us from estimating the particles of the ether. So you can see he's talking about the particles, right, of the ether. To be of a substance as nearly approaching to perfect hardness and possessing a springiness as prompt as we choose. In other words, he's saying, look, the particles are hard, and they're all individual particles. And the only difference, I guess, with Newton is that they have a springiness to them. Okay, they have this vibrating motion. The particles of the ether, notwithstanding their smallness, are in turn composed of other parts. Okay. And that their springiness consists in the very rapid movement of a subtle matter which penetrates them from every side and constrains their structure to assume such a disposition as to give this fluid matter the most overt and easy passage possible. Okay, so Huygens is going to say, look, that's what I'm saying. I don't understand what the fight was about. They all believed in the ether. They all believed in particles, or in other words, that particles comprise the ether. In this sense, they were no different even than the Greeks. The Greeks believed that the ether was made of particles. They invented that. Huygens and Descartes and Newton, none of them came up with that. They simply borrowed from the Greeks. They said, okay, we have the ether. And the ether is that space, or that dark thing between the earth and the moon. Okay, that's the ether. What is it? Well, it's a bunch of particles. We can't see them. They're small, but these guys said they vibrate. I guess Newton was saying they just travel straight, or that light travels straight through them as a ball coming through. If you look at Descartes' book, the Dioptric, he wrote that in 1637. And he gives you a picture of the particle of light, just moving straight. And so he believed, Descartes, right, that light did travel straight as particles. And I think that's the new notion that Newton's going to borrow from him. Whereas, people like Hooke and Christian Huygens, they believe this thing goes up and down. And because it doesn't really move forward, it's kind of, you got this sandbox. And the grains of sand are moving up and down like maybe water. Water moves up and down. Well, this is the notion they had, that the ether was something like that. One of the problems with that is the difference, between a current and a wave, which I covered a couple of weeks ago. But let's go first with this. This is the difference between Newton and Huygens, as far as I can tell. Here, Christian Huygens, he's looking at these waves, ether as a bunch of waves. And Newton's looking at it as a bunch of particles, okay? And the only question I'd have for Mr. Huygens is, what are those waves made out of? And he tells us in his book. He says they're made out of particles. And so the question is, how is his ether different than Newton's? Well, Newton's is the particles travel straight. You can think of those as, or light traveling straight through the ether simply because its density is different. So there's many ways to interpret Newton because he was kind of brainstorming. He really didn't have it down solid in his mind. So he was kind of brainstorming. And he was saying, look, light travels straight, and because of this, it's because of the density of the ether. And whereas the Huygens said, look, it's just the vibration of the medium. And what is that medium made out of? Well, it's made out of particles. Okay, so this is what these folks were thinking of in those days. And a lot of that we inherited today. And okay, and here we have the issue that I just mentioned a minute ago. Waves. You can talk about waves as surface things. What goes underwater is called a current, not a wave. You don't have waves underwater. When these people say they detected gravity waves from colliding black holes, well, obviously they're talking nonsense because you don't have waves inside the ocean, the cosmic ocean. You can't have waves. What you can have is currents. You can talk about currents maybe, right? Assuming the cosmic ocean is made out of some kind of ether, well, then you can say, yeah, there's a current, underwater current, so to speak, an ocean current. But when you're talking about waves, you're talking about surface things. And that makes the notion that you have waves coming through the ether, through the body of the cosmos, it makes it surrealistic because you're putting a two-dimensional scenario, you're embedding it within a three-dimensional medium. Okay, and this is where the problem really goes with the waves. Okay, let me get myself back in here. Got so many of these, sometimes I lose track. Okay, so where do we go from here? Well, Newton won the day on his authority. Newton was such a powerful guy as a mathematician. He had a lot of credit, especially from the French and the British, English, that he carried a lot of weight. He was a celebrity. For those days, he was known throughout Europe as the guy to consult if you had a problem with mathematics. He was the guy. Leibniz in Germany, he rivaled Newton. They both came up with a calculus like independently. And they all discussed these issues in different ways. They discussed the nature of the universe, the nature of the ether. Was it infinite? Those questions popped up. And this lasted on Newton's authority. Everybody believed essentially in the particle notion of the ether and so on until the 19th century. And the 19th century, it's going to be his countryman, Thomas Young, who at the beginning of the century, 1800, he started doing some experiments using Newton's experiment. He took Newton's diffraction experiment, which was with a hair, and that came already from a Italian priest that preceded him. So all this stuff just came to the 19th century, served in a gold platter to Thomas Young. Thomas Young decided to repeat these experiments, and Grimaldi's experiment, this guy who came up with it first, and he did experiments, trying to break the beam of light in two, and he did what is known as the slit experiment. And that was in 1800, 1801, 1802. He gives his dissertations at the Royal Society. And so he comes up with this idea of the wave, but he wasn't believed because Newton's authority was so great. Ring any bells? Einstein's authority is so great that nobody's going to question him today, right? Well, that's the situation that Thomas Young faced. He said, I'm just a little old guy here. I'm a physicist. I'm studying. I'm telling you, I think light is made of waves. No, you're wrong. See, Newton said, and that's the way it was handled. But it turns out that the French, the other side of the channel, also began to study light in earnest in those days. And you had several of them. You had Malus, who discovered certain aspects of polarization. You had Arago, you had Fresnel, and all these guys, they started looking at light, and they liked what they saw from Thomas Young. They said, oh, maybe Thomas Young is onto something. And it would be really Fresnel, Augustin Fresnel, who would come up with some good ideas that light really had a wave nature. He's the guy who really imposes the wave nature of light on the world. And originally he wrote a paper in, in 1816, 1815, and 1816 originally. And he kept developing his idea. He was trying to figure out an explanation for Thomas Young's slit experiment. And so he can come up with the idea that light really consists of longitudinal waves. This is what he was thinking of. But he does mention in his 1819 paper, okay, he already comes up with a notion of the transverse motion in there. He's got a couple entries there. Okay, this is directly from his paper. Okay, and he talks about transverse pressures. Okay, so that kind of he was already kicking around this in the back of his mind, and it's going to take him 2 years until he finally figures out that maybe it's not a longitudinal wave. Maybe it is a transverse wave. And he needs that transverse wave to be able to explain polarization. That's where the issue comes. He needs to explain polarization. He does explain polarization as with his picket fence scenario. He says, look, imagine light consists of transverse waves. You have one up and down, the other one sideways. And a picket fence would knock the horizontal component of light and allows through it the vertical component, right? And when it reaches the second polarizer, if that one's in a horizontal direction with respect to the first, that one blocks out the vertical component that went by, and that's why you have extinction. That's why the polarizer can extinguish a beam of light just by turning it 90 degrees. So again, what you have here is, you have light coming in. It's got two components. They're both transverse components. In other words, transverse means that it moves perpendicular to the direction of motion of light. So if you put the first polarizer with all the atoms or molecules aligned vertically, it's going to block the horizontal component. And the second polarizer, we know for a fact, extinguishes light altogether. Why? Because it blocks the remaining vertical component. That's the way he explained it. And people like that because at least they could visualize now why a polarizing material could block light just by turning it 90 degrees. That was magic since Grimaldi discovered it in the 16th century. Okay, so Fresnel is going to really kick in the wave nature of light, and it's just going to advance more and more and more throughout the 19th century to the point where everybody just believed in the wave nature of light. They forgot about Newton altogether. The particle model was buried and died. Nobody talked about it. But it turns out that we still had the ether. And what was the ether made out of? Made out of particles. And so we have all these contradictions that have not been resolved, by the way, until today, right? Because people keep talking about the ether in different ways. They'll call it space-time. They'll call it the false vacuum. They've got all these terms for it, you know. Essentially, the ether is the vacuum is not empty. It's made out of ether. Its name has changed, but it's still the same particle-filled space, and so that lasted throughout the 19th century. They just forgot about Newton and particles. We went into the wave theory of light, and we have every experiment done in the 19th century points to the wave theory, from from Faraday, Maxwell, all these people that are going to talk about light. They're just going to talk about the movement, the wavy motion of the ether. And so I'm going to be dealing with that on Sunday. I'm going to go over the 19th century, find out what happened throughout that great century, which we left behind when we brought what? Quantum mechanics. That was the 20th century. 20th century trumped the 19th century. Okay, we'll see you on Wednesday. We'll continue with nothing. We'll see you then. Bye-bye.